Okay, the lesson is on recording now. Okay, now today we will be doing factorization. Now I'm going to list down all the techniques of factorization, and then we will see what kind of expression will have to be taken through which kind of process of the factorization. And the first technique is common technique. You take common from the given terms. I'll take you through each process one by one. For now, I just want you to make a list of all the techniques. Now, these are the techniques of factorization. The second one is by using algebraic identities. The three identities which we studied for the expansion purpose, we can use the same identities for the factorization purpose. The third technique is by a middle term breaking method. Okay, now by using algebraic identities, you can only factorize quadratic expressions. I'll tell you what are actually quadratic expressions. And by using a middle term breaking method, you can again factorize only quadratic expressions or coded quadratics. I'll tell you what are these basically. So these are the three techniques which are mainly used in order to factorize. Okay, now we will be discussing the cases like when to use which kind of technique in order to factorize. Now, it is important to know these cases because when you get a question in exam, many students, first of all, they are not able to identify what kind of expression they have, and they end up applying the wrong technique, and then they decide to leave the question as it is. So you need to understand the type of the expression. So before I jump to the cases, actually, let's just discuss the types of expressions. The difference between an expression and equation, anyone? If there is anyone who want to tell the difference between an
There is
expression
the
and
sign of is equal to and there is no is equal to.
well, in an expression, we can have the equality sign as well. For example, if I have a plus b whole square, then I can put the equality sign before it, before expanding. So this is still an expression. So how would you differentiate between an expression and an equation? Hmm? Okay, in an equation, yes, we do have the equality sign, but we have an expression on the left-hand side of the equality sign, and then we have an expression on the right-hand side of the equality sign as well. That makes the equation. Like any formula in any subject you study, like let's just talk about, for example, the area of the circle, which is given by pi r square. Now, this is the formula which is technically an equation. So A equals pi r square. So we have a thing on the left-hand side of the equality, and we have a thing on the right-hand side of the equality, which makes this as an equation. What will be expression? Just pi r square. This is an expression, so we do not know what is giving, like what is pi r square giving us, and what is this equal to. So that leaves us with an expression. We are practicing all the tools like factorization, expansion on the expression, and then we will take to the equation later on. Okay, so types of expression. The first is a linear one. Anyone who can explain what is a linear expression?
Has the power of 1.
Has a maximum power of 1. For example, ax, actually let's just use numbers instead of constants. 2x plus 3. So we have just one variable over here, and it has a maximum power of 1. So this is a linear expression, or 2x plus 3y. So again, in this case, whatever variables are involved, they have a maximum power of 1. So they are categorized as linear expression. And then we have quadratic expressions. What are quadratic expressions?
ax squared plus bx plus c.
Yeah, in which we have a maximum power of 2. So a general example is ax squared plus bx plus c, or just ax squared. This is also a quadratic expression, or a plus b, or something plus x whole square. Let me just put it that way. So 2 plus x whole square. Now all these are quadratic expressions. Now why is this one a quadratic expression? Because you know when you will expand this, you will have x squared inside it. So that makes this one as a quadratic expression. Okay, not going to talk about cubic and quartic for now, but there is another thing which is known as exponential expressions. What do we mean by exponential expressions? Okay, exponential expressions are those in which we have a variable as a power. Now, if you look in the linear, whatever the variables were involved, they all had a maximum power of 1, and the variables were not power. Okay, now in the second one, which was quadratic, whatever variables were involved, they had a maximum power of 2. Okay, so that makes it a quadratic expression. In an exponential expression, the variable becomes a power itself. So variable is a power. So whenever you have a variable as a power of something, that is basically an exponential expression. Okay, now the fourth one, coded quadratics are basically, for example, if you have a quartic expression is the one, like the way we have a maximum power of 2 in a quadratic expression, quartic expression will have a maximum power of 4. Now, ax power 4, for example, plus bx squared plus c. Now, you see that the maximum power of a variable over here is 4. Now, this makes it a quartic expression. Now, in your syllabus, like there is no technique to factorize a quadratic. Like in your syllabus, there are actually techniques, but IGCSE syllabus or O-level syllabus, they do not have a technique in order to factorize a quartic expression. So what you do is you take them as a coded quadratics. Now, what are coded quadratics? You try changing them to a quadratic one. Now, you assume that y equals to x squared. So if y equals to x squared, then this x squared can be written as y, and this x power 4 will be written as
Y square.
y square. Excellent. So ay square plus by plus c. So this makes a quadratic one. Now, when it is an equation, for example, if you get a question in which you are given with a coded quadratic equation and they ask you to solve it, so basically you decode the quadratic equation, change it to the quadratic one, solve the new one, and then go back to the original one. We will do this later on. Don't worry about it if it's confusing for now. So these are all the types of expressions you will be dealing with. Okay, now jumping to the cases. Case one, you get a question and they ask you to factorize it. I want you to write down these cases on a separate piece of paper so that you can refer to these cases before factorizing the question. Okay, now case one is whenever you have two terms and you have a positive sign between them, you always take a common. How to take a common and what is the actual meaning of common, I'll tell you that later on. So this is the case one. Whenever you have two terms, regardless of that it is this whole expression is linear or quadratic or coded quadratic or whatever it is. Whenever you have two terms and you have a positive sign between them, just simply take a common from the both terms. Okay, now the case two, if you have two terms again and you have a minus sign between them. Now the first priority would be check if you can write down each term as a square of something. If you are able to do that, then recall the third identity. Let me just take you the third identity. Well, you should know the identities by heart. Now look at the third identity, look at the expanded form. So whenever you have an expression in an expanded form like a squared minus b squared, then the factors will always be a plus b into a minus b. So let me give you a quick example as well. So this will be, then you will apply a third identity. For example, you have 16 minus x squared. Now, if the examiner asks you to factorize it, now you see there are two terms and there is a minus sign between them. So I will check if I can write down each term as a square of something. 16 is a square of 4 and x squared is a square of x. So I am able to write down each term as a square of something. So whenever I have this a squared minus b squared, the factors are a plus b times a minus b. So this is how you will be factorizing. Okay, we'll be doing these examples later on. I'll be practicing few questions with you while you have all the cases in front of you. The second priority, if you are not able to write down each term as a square of something, then you will take a common. Okay. All right. Case 3. If you have three terms and these three terms are basically a quadratic ones. If they are quadratic, then you can factorize them by using a middle term breaking method. So that's the technique which I asked you to write it down over here, which was the third technique here, middle term breaking method. Or sometimes you can factorize a three-term quadratic by completing a square. Now, completing square technique is basically by using first and second identity. Okay, right. So this was case 3, wherever you have three terms and the three terms are basically quadratic expressions. Okay, now case 4, or actually let's just stick to case 3. What if the three terms are non-quadratic? Then you take common. All right. Now, this was case number 3. Now moving on to case number 4. Whenever you have four terms, A, B, C, and D, then what you do is you take common, but there is a separate way of taking common for this one. Common by grouping. So you will make groups. Now, how do you make groups? First of all, always try to use the same order given by the examiner. So make a group of A and B. So you will take common just from the first two terms, and then you will take a separate common from the last two terms. If this does not work, then you can consider the rearrangement. Now, how would you do that? First and third, one group, and second and fourth, another group. So A plus C, one group, and B plus D, another group. If this doesn't work as well, then you can consider rearranging further. First and last one group, and then second and third as one group. Definitely you will be able to take common from either of these three. So this is how you take common by grouping. Now I would like to take you through the techniques, that how do we actually apply the techniques. Now these are just, I told you the what are the techniques over here. And the first one was common. Now let's just talk about how to take a common here. So over here I'm going to talk about the techniques now. These were the cases that when to use which technique in order to factorize it, so that you have a clear picture about what kind of expression you are dealing with, how you are going to factorize it. So you should be able to, like, your practice should be set straight by looking at the question. A technique should pop up in your head. Okay, this is how I'm going to factorize this, because there are different methods of factorizing. Okay, now let's just see how each of the technique works. Now, first of all, common. Now, everyone knows how to take a common for the factorization purpose. Now, common is, by taking common is just a tool. It's not completely associated with the factorization purpose. Now, common for the factorization, it's different, but taking common is actually a different tool, and it works in a totally in a different way. Now, let me explain you. For example, if I have a question like 2x squared plus 4x, now these are the two terms, and I need to factorize this. Now, by taking common for the factorization purpose, now focus on my words. Now, taking common for the factorization purpose. Okay, how do you take common for the factorization purpose? Focus on the numbers. So I have 2, and then I have a number 4. Now I have to think of a number which can be divided, largest possible number which can be divided on both. Okay, largest possible number which can be divided on both. So 2 is a number which can be divided on both the numbers. Okay, that's the largest possible number. So I'll take 2 as common. Now from the variables I have, this is x squared, so it means I have 2 x's in the first term, and this is just x, so 1 x in the second term. So technically I have just one of the x as common. So I can take x as a common from the variable. So 2 times 1, no, so what have you taken as common? This 2. Now you need to check 2 times what is this 2. So 2 times 1 is this 2. So you basically put 1. 1x is gone out as common inside plus. Now again, 2 times what is this 4? 2 times 2 is 4. 1x is out as common, so nothing left inside. So 1x plus 2. So 2x is basically x plus 2. Another quick example. 4x squared, actually 6x squared plus 3x. Now, if this is a question and the examiner asks you to factorize, and I can clearly see I have 2 terms and I have a positive sign between them. So only way I can factorize them is by taking common. So you need to think of a number, largest possible number, which can be divided on both the numbers. So that is definitely 3. So I will take 3 as common. Again, the same case for the x's here. 2 x's here, 1 x here, so 1 x would be common. So 3 times 2 is 6, so I'm left with 2 inside, and 1x is out as a common, so I'm just left with 1 more x, which is inside, plus, okay, 3x is common, and I have 3x itself, so I'll be left with 1. I have seen students putting 0 because they say 3x is gone out as a common. Just a minute, hold on, please. Okay, sorry for that. Okay, so do not put 0 thinking that 3x was taken out as common, so there is nothing left here. No, we are dealing with factors. So if there is nothing here, so it has to be 1 over here because 3x times 1 makes it 3x. You can always apply the reverse process just to check if you have done the factorization correctly or not. So let's just apply the reverse process. So 3 times 2 is like 6. A reverse process as an expanded. So 3 times 2 is 6. X times x is x squared. So I've got the first term right. So 3x times 0 will give me totally 0. So that is, this means that this 0 is wrong here. So it has to be 1 because 3x times 1 will give me 3x. So this is how you take common. Now let me tell you the actual meaning of taking common. Now what do we actually mean by taking a common? For example, 3x plus 4. These are the two terms, and if I ask you to take common, I'm not asking you to factorize it. Okay, I'm not asking you to factorize it. Now over here on the left hand side, I have used a process of taking common in order to factorize. Okay, taking common and factorize, they are the two different things. I am using a process of taking common in order to factorize on the left hand side. On the right hand side, now I'm going to actually tell you what do we actually mean by taking common. So first of all, let's just do the same question which I did on the left hand side. Now when I say I take 2x as common, what do I actually mean? Whatever you are taking common, you are actually dividing the same thing with each term, which is a hidden process, which you do not show here. So when I take 2x as common, I am actually dividing 2x with each of the term here separately. Now, if you solve this, 2 can be cancelled out with 2x, 1x can be cancelled out with one of the x's on top, 2 times 2 is 4 and x is gone. So you are left with x plus 2 inside. So this is the actual process of taking common. Like whatever you take common, you divide with each of the term. So you are using a process of taking common in order to factorize. Now, why am I emphasizing on this? For example, if you have a question as 3x plus 4. Now, the question is take 3 as common from here. Can you take 3 as common?
No, sir.
You cannot take 3 as common in order to factorize, which is totally different. My question is not to factorize. I'm not asking you to factorize it. I'm just asking you to take common, not for the
Sir,
factorization.
if you look at the numbers, we can't take 3 as common.
We
Well,
can
well,
We're
take
not.
you
1 as
are
common.
you are mixing the factorization again. That was the rule for the factorization purpose. When you are using take a process of common for the purpose of factorization, then that was the rule that you need to look for a number, largest possible number, which can be divided on both. That was strictly for the factorization purpose. Now I'm using, I'm not using this for the factorization purpose. I'm just taking common. I can take anything as common. So for example, I say if I want to take 3 as common, all I have to do is divide 3 with each of the term. Yes, there we go. 3 is taken as common. Are you getting my point? You can check this theory by expanding this 3 times, just for the checking purpose, 3 times x by 3 plus 3 times 4 by 3. You will end up with exactly same thing. Okay, sorry, we have 3x over here. So 3 times 3x. So you are left with 3x plus 4. Back to the same thing. So you can take anything as common. Why I am teaching you this thing, that what is actually taking common means, because we will be using this later on while doing the completing square methods. Got it?
Yes,
Yes,
sir.
sir.
Now, one last thing. For example, if you have 2x plus 4 whole square, now I know this is already a factor. 2x plus 4 whole square is already in a factor form. 2x plus 4 whole square means 2x plus 4 into 2x plus 4. But still, if I ask you that factorize the terms of these factor, like whatever is inside the brackets, many students, they do it like this. They take 2 as common and they are left with 2x, sorry, and they write it down like this, x plus 2 whole square. This is wrong. You cannot do this because you are bounded in a square. So you can take 2 as common, but with the square, then it's correct. So 2 square as common, and then you can be left with x plus 2 whole square. This is correct. Got it?
Sir, it means that we have to take the square.
Yes. If you are taking common from a thing which is bounded by a square or a square root or any other power. If it's bounded by a square root, then whatever you take common, that root will come out as it is.
Okay, sir.
All right. So this is how you take common. So this is how you factorize by taking a common. Okay. Now the next thing and the important thing is by using a middle term breaking method. So this is important. I'm going to write down the steps here. Please use those. If you now there are many different techniques in order to break the middle term. Now all I want you to understand the logic behind it. I don't want you to change the method, whatever you know from before. My main purpose is to explain you the logic behind breaking the middle term. Now, for example, I can only use middle term breaking method when I have a quadratic expression. Now, for example, I have a question: x squared plus 5x plus 6. Okay, now the question comes in as factorize. Now when I see at this question, I can see clearly that this one is a quadratic one. So my first priority would be a middle term breaking method. Now, what do we actually mean by a middle term breaking method? For example, if the same question is has shuffled terms, then is this going to be a middle term? X squared? No. By a middle term, we strictly means a linear variable term. Like this is a quadratic term here having a power of 2. This is a constant term here, and this one is a linear term, like a variable with a power of 1. So middle term strictly refers to the linear variable term. Remember this. If you have a shuffled expression, so this always applies to that. Linear variable term is a quadratic one. So whenever you get a shuffled question, make sure you rearrange it in the descending powers of x, and then you will try to break the middle term. Now 5x is the middle term over here. Now what is going to happen? X squared will stay as it is, 6 will stay as it is, 5x will be broken down into 2 further terms. Now what do we have? How many terms do we have? 4. We will end up with 4 terms. This is all the middle term breaking. So once you have 4 terms, then what you do? Common by grouping. The case number 4. Okay, now how do we actually break the middle term? So whenever you break the middle term, make sure do not change the question. B and C, when dissolved together in order to go back, they should give you 5x. Remember that. So whenever we are trying to break the middle term, we do not intend to change the question. Okay, now the process is step 1. I'm going to write down the steps by keeping the standard form of the quadratic expression in mind. A is the coefficient of x squared, B is the coefficient of x, C is the constant term. Okay, so whenever I am asked to factorize, the first thing I'm going to do is I'm going to multiply C with A, like the constant with the coefficient of x squared, which in this case is 6 times 1. So I'm going to put that number on a side. So this will, let's just say this result in a number A, which in our case is 6. Now I have to think of the two numbers. Step number 2. Think of two numbers when multiplied you should get A, which comes from here. Over here, if I try to put that down, I need to look for the two numbers which when multiplied I should get 6. And when the very two same numbers when added or subtracted, I should get the coefficient of the linear term with the sign, which is plus 5 in this case. So over here, added or subtracted, I should get B, which is the coefficient of the linear term over here.
So it's
Okay,
gonna be 90, right?
it has to be 1, either add or subtract. Now, how do we get that idea? By looking at the sign of the constant term. This defines what do we have to do. Now, we have a positive sign with the constant term, so we are going to definitely add the two numbers in order to get plus 5. So this sign helps you determine that if you need to add them or you need to find the difference of the two numbers in order to obtain a required number. Okay, now in this case, definitely 2 times 3 is 6, then 2 add 3 is 5. So x squared plus 5x will be broken down into 2x and 3x. Because I have 5x, I have broken that down into the two terms, 2x and 3x. Now you need to check, make a habit of checking, dissolve these two, plus 2x plus 3x. Is it actually giving you plus 5x? Yes, you're good to go. Means you haven't changed the question, which you do not want to do. Okay, now with this, we'll kill two birds with one stone. I'm telling you how to take the case. I'll be talking about case 4, like taking common by grouping. Okay, now first two groups and then the second two groups. From the first two groups, I can take x as common, and I have x plus 2 left inside, plus 3 as common, and then I am left with x plus 2. Okay, now this is the first, and now I'm going to take common one more time because this makes it one term and this is another term. Earlier I had 4 terms, now I have 2 terms. Now I need to put it down into the factor form. For that I can clearly see in both terms x plus 2 is a common factor. So I will take x plus 2 as common, and then I'll be left with x plus 3. So this is how you factorize by using a middle term breaking method. Now, I would like you to take to the practice questions from the past papers so that you can actually see how you are going to factorize it. Okay, now look at this, factorize. I hope you have the written cases, all of the cases in front of you. So how many terms do we have over here?
2
2. What is the sign between the two terms?
plus.
Addition.
Positive sign. So what technique am I supposed to use here?
Factorize.
No, no, I am
Common.
right. What technique? By taking common. So what is
Common.
common in both terms? X squared is a
X
common
square.
factor in both terms with a plus b. That's it. Okay, now Look for another question with the command word of factorize. This is expand and simplify. This is solve. This is algebraic manipulation, expand and simplify, algebraic fractions, manipulation, fractions, solve. Okay, factorization. Okay, factorize completely. How many terms do we have here? Question number 28.
Sir, 2.
What sign do we have between the two terms?
Minus.
Whenever I have two terms and I have a negative sign between the two terms, my first priority would be to check if I can write down each term as a square of something. So there is no need to check like by writing it down. You can do it in your head. Is 2 a square of any number?
No.
No. So that denies the first priority. Now, what was the second step? Like once you cannot factorize by using the third identity,
Common?
you take a common. Yes. So if you focus on the numbers, 2 is the largest possible number which can be divided on both. And from the
And then y.
variables, I just have y as common. So 2 is gone out as common. I'm left with x, y is common, so forget about it. Minus 2 times 2 is 4, y is gone out as common, and then z. This is your final answer. While I'm explaining, if there is any student who think she can do it, then I'll be very happy if someone speeds up with their work. Okay, now how many terms do we have here?
4.
4.
4.
4 terms. So by grouping, so what is the common from the first two?
X.
X.
I'm left with a plus b. What is common from the
And then
last
y.
two?
Y.
Y. And then a plus b. Okay, now here's a common mistake. Many students, they forget to put this plus or whatever sign is over here. Make sure you put a sign because this y is not being multiplied with this a and b. Okay, so I have separated this and this whole thing. So this
Sir, I have a
sign has
question.
to come. Yep.
Sir, we can also group like AX with AY and BX with BY.
You're saying ax with by?
No, AX with AY and BX with BY.
Yep, you can. So what is common from the first two terms? A, you're left with x plus y. From the last two terms, you have b as common. You're left with x plus y. Make sure they have to be same. X plus y is taken out as common. Then we have a plus b. Now the students know they have to be same. So the first one is fine. The second one, they make it same forcefully. No, do not do that. Make sure it turns out same logically. Do not have that thing in your mind that it has to be same as the first one. Okay? Do not force it out of it. So because if it's not coming same, then it means you're making a mistake somewhere. Okay, this is two terms, positive sign. Clearly you have to take common, which we have done it already. So I'm not going to waste time on that. Okay, solve, expand the brackets. Something that we are actually missing. I just skipped through a question. I just realized. Okay, how many terms do I have in the numerator? Now this
3.
is simplify fully. Definitely, we will be able to simplify it once it's in a factor form. So let's just talk about the numerator first. So x squared minus x minus 20. How many terms do we have? 3.
3.
3.
Is this a quadratic or non-quadratic?
Quadratic.
Non-quadratic.
No, no, this is quadratic. You see, what is the maximum power of x here? 2. So this is a quadratic. So if this is a quadratic, you can always go for the middle term breaking method. Now, what is the middle term over here? Minus x. Okay, now following the same steps. 20 multiplied by 1 is 20. So I need to look for two numbers. When multiplied, I should get 20. And the very same numbers, added or subtracted?
Subtracted.
Excellent. This sign tells us what we have to do. So in this case, we have to find a difference of the two
Sir,
numbers in order to get -1. Okay, now think of the two
so sir,
numbers.
it
Yeah,
will be 4x minus 5x.
plus 4x minus 5x. So you're saying 4 into 5 and then 4 minus 5. Yeah, good. Okay, so x squared plus 4x minus 5x minus 20. Now just check. Plus 4x minus 5x, it has to give you back minus 1x. So that, because you don't want to change the question. Okay, now common from the first two, common from the last two, and then x plus 4 is common factor in both terms, and I'm left with x minus 5. Okay, now talking about the denominator, which is x cubed minus 10x squared plus 25x. Is this a quadratic? How many? This is three terms, but is this a quadratic or non-quadratic?
Non-quadratic.
Whenever we have a non-quadratic three terms, what do we do?
Common.
Excellent. Okay, now we will not jump to the middle term breaking. We will take common. So what is common from all three?
X.
X. X is common from all three. So I have taken X as common from all the three terms. Now I'm left with X squared in the first term, 10X in the first term, sorry, second term, and then 25 in the last term. Is that all?
Yes.
Yes, sir.
No. I can see this is a quadratic factor, x squared minus 10x plus 25. I can clearly factorize this further.
So sir, we can use middle term break method.
Yes.
Yes. Excellent. So 25 times 1 is 25. So I need to look for the two numbers. When multiplied, you should get 25. And when added, you
Minus
should get
5x and
minus
minus
10.
5x. Both minus
Excellent.
5x.
So this is going to be x squared minus 5x plus 25. Now x is common, x minus 5. Now minus 5 is common. Now as I have taken minus 5 common from these two terms, which will change the signs. Whenever you take a negative sign as common, it changes the sign. So this term, the first term of the highlighted part is negative. So now it will be positive, positive x. The second term of the highlighted part is positive, which will be changed to negative. Now 5 times 5 is 25. See, logically same, not forcefully, okay? So x into x minus 5 into x minus 5. Okay, now you can put these two in as a numerator or and the denominator. So in the numerator, I will have x plus 4 into x minus 5, because x squared minus x minus 20 can be factorized as this. And in the denominator, I can have x into x minus 5 into x minus 5.
So
Now I
sir,
can
we can
take out the
cancel the
factor
x minus
x
5.
minus 5, x minus 5. I am left with x plus 4 over x into x minus 5. Got it? Now, where do students lose marks in these kind of questions? Because they cancel out x squared with maybe this x squared. I have seen these kinds of mistakes. Please do not do these kinds of mistakes, okay? You cannot cancel out the terms. You can only cancel out the factors. Like x minus 5 over here was a factor. X minus 5 over here was a factor, the whole as a factor. Only then I was able to cancel it out. Even if I had like x plus 4 plus sign between them, then I won't be able to cancel it out, because then it won't be a factor. Factors are basically things which are being multiplied. Okay, now expand the brackets. I'm looking for something tricky over here, but okay, now look at this question. H squared minus h minus 20. Forget about the numerator. Let's just talk about the denominator. How many terms do we have in the denominator?
2.
2
What sign do we have between them?
minus.
So
Negative
the
sign.
priority would be to check if you can write each term as a square of something. So the first one is already a square of h.
Second
25,
is
isn't it?
square of 5.
Yes, so I can rewrite this as a square of 5. So whenever I have an expression in an expanded form like this, I know the factors are as a plus b into a minus b. So these are the two factors. You know how to factorize the numerator by middle term breaking method. Correct?
Yes, sir. Sir, in the end, then we'll simplify the like terms, right?
Like factors,
As in
not like
cancel
terms.
out the like terms.
Yeah, cancel out the like
Yeah,
factors.
sorry.
Okay, not the terms.
Yeah.
Okay, now, well, before we leave, I would like you to quickly do which question? Okay, these three questions, which you can, two questions actually, which you can see on the, actually, no, wait a minute. These two questions, which you can see on the screen. Before our next class, it would be very good for you, like if you practice all the factorization questions. Now you know where to look for the questions of these kinds, all the questions with the command word of factorize, and all the questions where you see simplify, and then you see one fraction, and then you see the expressions in the numerator and then in the denominator. But it has to be one fraction. Do not do multiple fraction simplification when you have a plus or minus sign between each fraction. We haven't done that. We haven't done that yet. So we're just dealing with single fraction with the numerator and denominator so that we can factorize it and then cancel out the like factors. So it will be excellent if you practice all of these. It will be very, very convenient for you because we need to proceed. In the next class, we'll be moving ahead. So only the next things will only make sense if you are really good on the previous things. So practice all these kinds of questions from the same worksheet, which is already on our Google Classrooms. This question is very easy. The answer to part A is basically used in part B in order to simplify.
Sir, I've done
Done?
both the questions. Yes, sir.
Excellent.
Sir, the
Excellent.
answer of first question, shall I answer it?
Just hold on a minute. Let's just wait for others to do it. Who is still
Sir,
trying to factorize it? Yes, Myra, you were saying something?
yeah, I was gonna ask, like, we're going to use the answer from part A in part B as well, right?
Yeah, because you have the same expression as the denominator in part B, if you
Yes.
notice it. Okay. Now, is there anyone who is still trying? Okay, so I'm just going to do this quickly. 30 times 1 is 30. So you need two numbers. When multiplied, you should get 30. And when the very same numbers, when subtracted, you should get plus 1. 6 times 5. So x squared plus x, sorry, plus 6x minus 5x minus 30. X into x plus 6 minus 5 is common, and then x plus 6 by logic, not forcefully. Okay, I have taken a negative sign as common, due to which the signs of each of these terms will be changed. Now both of these are negative, they both will be positive inside. X is also positive, 6 is also positive. X plus 6 is common, and then we have x minus 5. So x minus 5 into x plus 4 over x plus 6 into x minus 5. You're left with x plus 4 over x plus 6. Now last thing, I'm not okay. Now remember why I'm doing this 30 times 1, because many students, they create this idea, because many questions comes in such a way where you have 1 as a coefficient of x square. So many students create this idea that this has to be the number over here. No. For example, if you get a question where you have 2 over here, so make a habit of multiplying it, because now this time when you have 2, 30 times 2 would be 60. Then you will be looking for two numbers. When multiplied, you should get 60. So this is the important point to remember. That's it for today. Practice it. You have the marking key at the end of this worksheet. If you encounter any problem, do let me know. And the only benefit of moving forward is if you are getting whatever I have taught. If you haven't got a single thing of algebra up till now, you can easily, comfortably ask. We can practice the same thing in the next class. See you in the next class. Allah
Allah
Hafiz.
Thank you,
Hafiz.
sir. Allah Hafiz.
से थोड़ा सा नीचे करेंगे मैं स्क्रीनशॉट ले लूँ
Okay.
थैंक यू सर
Welcome.
पार्ट
बी पार्ट नजर नहीं आ रहा
जी
अभी
एक मिनट
अभी ठीक है
जी सर